So far this week we have discussed the energy management system. We talked about SCADA systems and how the control landscape of a power grid looks like between the control rooms and the remote substations. In this video, we will look at modern power system substations and the effort to digitize them. We will discuss the architecture, the benefits they offer, and see which functions are located. Traditional substations, which you see here, contain large transformer devices, circuit breakers, switches, support structures, and so on. There are many bus bars, cables, and lines, which are bulky and need lots of space due to the required safety distances. Typical voltage levels in Europe are in the order of hundreds of kilovolts, stepped up and down by transformers. Equipment that needs remote configuration, control, or measurement is connected via the SCADA system, originally via dedicated wiring for each sensor or actuator, and later via packet-switched telecommunication networks. Still, traditional substations are rather physical or even passive players. The moment we use IEDs, intelligent electronic devices, we create a digital substation. All processes are based on digital controls and are easily configurable via networks. Some functions can even work locally without the control center in the loop. Local networks connect these IEDs that perform the respective function. All measurements are digitized and offered to the control network, and all primary elements, such as the switches and transformers, have a digital module that enables remote operation. The IT architecture of these new substations can be broken down to 3 levels. The primary equipment is connected to the process level, the base of our architecture. Here we have the measurement units with sensory devices, which can be analog or digital. We can also merge data at this level. For instance, when measuring 3-phase voltages, we typically combine the measurements into one data package. So at the process level, we have sensors for current and voltage. We consolidate the data and send it via optical fibers to process it. The process bus sends measurements of interest to any interested device. One set of data can also be sent to a group of devices. We call this multicast. The recipients of consolidated data from the process level are located at the protection and control level, or the bay level. At this level, we have a set of control and protection devices specifically dedicated to particular power lines. This means we can have different bays in our substation for different lines. The big advantage here is that certain devices subscribe to certain data and receive exactly that, rather than flooding the system with information. Such a bay-level network reduces and simplifies wiring without jeopardizing the overview of what is happening in our system. Finally, above that, we have the station control area, which is, as the name indicates, on station level. This is where the communication and coordination within the entire substation and with the control center happens. Here we might also have central functions such as a GPS clock, which are used to time synchronize all the devices in the substation. Another digital element that you might find in a digital substation are non-conventional current transducers, also referred to as non-conventional CTs. They are sensors to measure current, but unlike traditional ones that are basically small transformers, measurement transformers, they use a magneto-optical material and the Faraday effect with polarized light in an optical fiber. The phase shift of the reflected light is used to measure the current. Such CTs are linear, they are fast, they are perfectly safe because the optical fiber is basically a galvanic insulation. It does not pick up any electromagnetic noise at all. At the ID, the signals are converted to digital data and offered to substation applications. We have already come across many of the benefits of digital substations, but let's recap these benefits here. To begin with, digital remote access is fast, flexible, and saves time. Another benefit is that the electrical signals are now digitized right at the source, maybe with a non-conventional transducer using fiber optics and with less copper involved. This makes signal processing and handling much simpler and more robust. We also get improved measuring accuracy and performance, as well as everything we need in order to do sophisticated analytics and troubleshooting. By that, it contributes to improved reliability and availability. For me, the most compelling advantage is easy configuration or reconfiguration or replacement of device functions. Digital substations also have a positive safety impact and can reduce costs of equipment, components, space, and material use, largely because of all the above benefits. Let's wrap up. In this video, we introduced the digital substation, its architecture, and listed some of its benefits. Thank you for watching.